everyone, how are you all? So, welcome back to the session of mixture and pure substances, which we were discussing from the last two sessions. So, what the thing, student, that yes, we have covered up 80%, I can say, not 80, uh 70%. Okay, fine. So we have covered up 70% of this chapter, and that means we have left 30% of this chapter. So in this session we are going to cover up all of the topics, and after that this chapter is going to be completed. Fine. So now, student, what the thing is that I just want to revise some points which we have studied in the last session. Do you remember what we have studied? So we have studied what are the elements, and then we have seen that what are the mixtures. Then we have seen that thing what are the types of the mixture, heterogeneous, homogeneous. Then what we have seen that what's the difference between the mixture and the compounds. Now what we are going to see is all of these topics. Now you'll say, ma'am, so many topics are here, but don't worry, student, these all are very simple, very simple. We don't have to give so much of time to each one of them. They are very simple. So that's how we are going to cover up all of these topics in this class. So it is just that what we are going to study today, it is the properties of compound, then method of separation of the constituent of mixture, that how we can separate out the substances from the mixture. So these all are the techniques, and these techniques are very simple. Don't worry that, ma'am, how many techniques are there, now we have to study so much. No, all of the topics are very easy. When we are going to just start the session and when we are covering up all of the topics one by one, you will say, ma'am, what it is, it is so simple. So don't worry. Now we are going to start with the topics. Okay, so the first topic of today's session is about the properties of compound. So students, that we are talking about the properties of compound. So if I ask you that as we have studied about the compound already, so what do you understand by the compound? So you'll say, ma'am, exactly, we have studied about the compound. So the compound is nothing but it is a we can say combination of elements, and when the elements combine together with the help of the chemical bond, then there is a formation of the compound. And what we have studied till now about the compound is that they are having the fixed proportion. Exactly, we have studied all of these points. Now we are going to discuss some more points about the compound. So first of all, elements are not easily separated by physical means. Obviously that the combination of the elements which are present in the compounds, they are not separated out physically, or we can say that easily we can't separate them out. For example, if I take the example of water, that is the H2O, that means H is bonded with the oxygen, and that's how, student, physically it is not possible to separate out the hydrogen and the oxygen in the water. Exactly. So that's how, student, it is first property of the compound, that the elements, or we can say that the compound which is made up of the combination of elements, those elements are not separated out easily by the physical means. Fine. Now what the second point is saying, so the compound has properties quite different from the element it is formed from. Exactly, student, like if we think that, okay, water is made up of hydrogen and oxygen. So hydrogen, exactly, it is I'm just giving you an example, it is made up of hydrogen and oxygen. So what the thing, student, that hydrogen and oxygen is what? They are gases. Exactly, but when they combine together to form the water, that is the H2O. So now what's the water is? It is liquid. So you can see, student, it is not always possible, or it is not like very must condition that the elements which are used for the formation of the compound, so the properties of the element is going to be transferred into the compound as well. So it's not like that. For as we have seen the example that the water is made up of like hydrogen and oxygen gases, but when they combine together to form the water, so then we are getting it in the liquid form. Exactly. So it's not like that, student, that the properties which the elements are having, so it's not like that all of these properties are going to be transferred into their compound as well. Fine. So that's the second property of the compounds. Fine. Now, the third point says that the formula of a compound summarizes the whole number atomic ratio of what it is made up of. Example, methane, that is the CH4, is composed of one carbon atom combined with 4 oxygen atoms. See, student, this point we have discussed so many times. As I have told you that what are the compounds, that the compounds are the combination of the elements, or we can say that when two or three elements combine together and form one compound, and those elements are present in what ratio? In a fixed ratio. As we have seen for the water, if it is requiring the two hydrogen, so two hydrogen will be there and one oxygen. That means one oxygen has bonded with the two of the hydrogen. Exactly. So that's how, student, they are present in the fixed ratio, and they are written in such a form that after looking at the formula, we come to know that okay, the structure of the water is containing two hydrogen and one oxygen. Exactly. For example, you can see here that it is the CH4. CH4, student, methane. It is a gas. Okay, methane is a gas, and it is also called as the greenhouse gas. So CH4, in CH4, student, what happened that the carbon and the hydrogen is bonded with each other. And what type of bond is there? Chemical bond is there, and that's how this is the structure of the CH4. That means four hydrogen has been attached with the one carbon atom only. So this is the structure, and it is the fixed ratio. It is not going to be changed for any condition. If it is a methane, so definitely there will be one carbon atom, and to that one carbon atom, four hydrogens are attached. Fine. So what we have seen till now, that the elements which are present into it, so what we have seen, that the elements which are present into the compounds, they are not separated by any physical means. Secondly, that the compounds are having the properties different from their elements. Exactly, that the elements which has been used up for the formation of the compound, it's not like that the properties of the elements are going to be transferred to the compound, or they are having the same property. Fine. And then what we have seen, that they are present in the fixed ratio, the elements we are talking about. And then the last point says that the word formula can also apply to elements. Example: hydrogen, oxygen, ozone, phosphorus. That means when the same type of the elements combining together to form a compound, then we can give a name also, like oxygen, hydrogen, ozone is there, phosphorus is there, when there is no mixture of any other element. Okay, so then we can give their name as well, like word formula can also apply to elements, that is the hydrogen H2, oxygen O2, ozone O3, phosphorus P4. So these all are the characteristics of the compound, students. Fine. Or we can say the properties, and we have discussed so much about the compound. It's just that we have find it out that okay, elements are not separated by physical means. Will you be able to separate out oxygen and hydrogen from the water with your hands? Exactly, no. That means by using a physical means, or by using physical processes, we can't separate them out. And as we have seen already, like hydrogen and oxygen, they are gases, but when they are combining to form the water, so water is what? Liquid. So definitely, student, properties are going to be changed. Gases and liquids are not having same properties. Fine. So these all are the properties of compound. Now what we are going to discuss here is, oh, why it is not okay. Okay, so what we are going to discuss now, it's just that we are going to discuss some of the separation methods so that we can separate out the substance from the mixture. Okay, so first of all, it is the hand picking. Hand picking, student, what it is mean, that this technique is used when there is a mixture of the solid components. Solid components, and we can see that those solid components are having some large size, not very big size like this much, not very, like they are having that much size that it can be visible by our eyes, that we can easily identify that okay, something is present there. So that handpicking method is used to separate out the solid components. For example, student, that whenever you have seen that whenever we have to cook rice, so what first your mother do is that she always clean rice. How? That if any small particle, or if any small stones or any other unwanted particles present there, so that she can remove it by using her hand. So she is using her hand and picking out all of the impurities. That is why this technique is called as the hand picking technique. Okay, now for that, students, I'm having one video, so I would like to show you that video. So here it is.
Separating solids from solids. Hand picking. Before washing rice for cooking, we first remove the paddy, husk, and stones from the mixture. This method is commonly used for separating slightly larger sized impurities like the pieces of dirt, stone, and husk from wheat, rice, or pulses.
So students, have you seen that what they are doing? That exactly by using their hand, they are picking out the large size of impurities. So that method is called as the hand picking method. And eventually then this hand picking method is generally used in our houses as well. Cereals or pulses which we are getting from the shop. So what happens, sometimes it could be possibilities that to some small stone would be there or something like that, so we can't eat it exactly. Or will you be able to eat stones? No. So what's the thing is that first of all what our mother do is that they always try to remove all of the impurities from that, and they use this hand picking method for that. Fine. Let's look now. You can see that how simple the techniques are. They are not very difficult. Hand picking is what? That removing the impurities by using your hand. Exactly. So that is the hand picking technique. Now the second is the threshing. So in threshing, student, what happened that this method is generally used up in the fields where the crop grows. So what happened that whenever the farmers say that okay, now crops has been grown up, and now we can see that for example there is a wheat. Now they have grown up the wheat. So what happened that to separate out the wheat from the we can say from other what the thing is that we called it as that stick. Okay, actually I'm not getting the correct word for it. So what happened, they just start using this threshing technique, and in this threshing technique what they do, they make a bundle of it and they just start beating it. When they just start beating it, so what will happen that the small you can say that the small size particles or small wheat are getting it is getting separated out from it. So that's how student threshing method is generally used up in the field process, like wherever we have to separate out the wheat, rice, or any cereals, pulses from the field. So what we do, that they just make a bundle of that sticks and they just start beating it, and that's how student the wheat or any cereal or pulses is getting separated out from it. As you can see here that this woman, what she has done is she has made the bundle of all of these. Bundle is there and she start beating it, and when she start beating it, so we can see here that these small particle, for example we can say wheat, is getting separated out from it. As you can imagine that we can't use the hand picking method here, because so many, like if it is a very big field, so you can imagine that how much of the crop has been grown at that point. So we can't pick out each and every wheat particle from there. Exactly, that's why student this threshing method is used up. They generally what do, they just make a bundle of it and they just start beating it, so that the wheat is going to be, or any other thing like wheat, rice, or pulse cereals, they are getting separate out from it. So this is the threshing method, students. Fine. Winnowing is a method which is used up for the, like in this method it is used for the with the help of the speed of wind. Okay, and this method is generally used to remove the very small impurities, like very light size impurities. Very light size impurities. What happens, students, that whenever the crop has been grown in the fields now, so what happened that for example it is a wheat. Okay, so wheat is there. So what happened that they are having some very small size impurities, that you can say it may be some kind of husk is there, or some kind of any that small grasses would be there that are very small. Also what happens, student, we can't separate them out by using our hands. So what we use the winnowing method. So in the winnowing method, student, what happened, as you can see in this picture, that a person stands over a height, like person is standing over a height. Person stands at some height. So what will happen, that they take some like you can see that she is taking some kind of we can say container or something like that, so that she can keep some amount of wheat in it. And you can see here that here it is the wheat. Fine. And when she is just pouring it from some height, so what will happen that the weight is of the heavy size as compared to the impurities. Exactly. So the weight is going to be fall down directly to the ground, and what will happen that the small size impurities, they just blowing away with the help of the wind. As you can see that these are the impurities, light size impurities. So these impurities are separating out from the wheat, and the large size of the particle, or we can say that the heavy size of the wheat grains, they are just falling down over the ground. So that's how, student, this winnowing method is used with the help of the wind, so that the very light size impurities are separated out from the crops. So this is the winnowing method, and it is done in the fields only by the farmers, but it's just that they just start using this method like when they stand over at some height, so that what will happen that when the wheat is falling down to the ground, so the impurities which are lighter in size, so they just get removed with the speed of the wind. Fine. So this is the winnowing method. So till now, students, we have discussed three of the techniques. So the first technique is the hand picking, second is the threshing, third is the winnowing. Fine. Now, if we talk about sieving, so students, the sieving method, it is used to separate out the impurities from very small size solid, we can say, or directly we can say as the powder form. So student, as you can see here, that this person is is doing that it is removing the impurities from maybe from any kind of the floor, and for that what they are using is they are using this strainer. Okay, see student, as we can see here that this strainer is having very small pore size, and this small pore size is why they are here, because what happens, student, that the floor which we are having, they generally present in a very powder form. Exactly. So what will happen when we have to remove the impurities from them that are very small in size? So what we have to do is we have to start using the strainer, because what will happen, the strainer is having some pores, and their pores are very, very small in size. So what will happen, only the powder, that means the powder part of the floor, is going to be separate out, and the impurities will left behind. So that's how, student, this is the sieving method in which we have to separate out the impurities from any powder like structure, and in this method we generally use strainer. For example, student, that if we talk about tea, that whenever we prepare tea, so we know this thing that the tea contains so many things. When we are adding milk or we are adding sugar, so it's just that they are going to be mixed up into it. But when we are adding the tea leaves, so it's just that those tea leaves are present in it, but we can't drink it. Exactly. So what will happen, we use the strainer so that we can remove it or we can separate out from them, and that's how we can use that tea. Exactly. So this is the sieving method, student, when we have to remove the impurity, or when we have to separate out some substance from a very powder form kind of thing, then we use the sieving method, and for that we generally use these strainers. Fine. Okay, now it's the sedimentation, decantation and filtration. So students, what happened in the sedimentation, decantation and filtration? So I'll just give you one example here. Let's say you are having a mixture of sand and water. And what type of mixture is sand and water, as we have talked about in the last session? Do you remember what type of the mixture is sand and water? Exactly. I hope all of you know the answer, that it is the heterogeneous mixture. Heterogeneous mixture. So what will happen, student, if it is the heterogeneous mixture? So the sand is not going to be dissolved completely into the water. So what happened, like in this picture, if you see that this is a beaker, and in this beaker you have taken some water and you have added the sand. Fine. And you just keep this beaker for 30 minutes or for 1 hour undisturbed. You are not going to be disturbed it for any time, like for even a single minute. So what will you observe after some time, that the sand is going to be settled down at the bottom. As you can see here, that this is the sand settling at the bottom. So when the sand is settling at the bottom, so this process is known as the sedimentation process. Now what we do, that as the water is present at the upper layer and the sand is settled at the bottom, so what we'll do, that we just and this water is called as the decantate. This is called as the decantate. So what will happen, we use the another beaker, and we just decanted this water into the another beaker. And what we have to do is we have to keep a very, like, we have to do this very carefully, so that the scent particle, that big scent particles which has been settled down, they are not going to be transferred into the other beaker. So the transferring of the decanted liquid into the another beaker, that process is called as the decantation. So as we can see, decantation is the process of gently pouring clear liquid into the another beaker without disturbing the sediment. As the sedimentation has been done, so the upper layer is only of the liquid, or we can say only of the water. So we are just transferring it very gently, so that no sediment particle is going to be transferred there. Okay. Now student, what happened, that we know this thing, that the sand is not only about the small particle, it is also having some dirt or something other impurities as well, which are very small in nature. So what happens student, that when we have to purify such water, so we do the filtration process. Now in that filtration process, what happens student, like you have collective water here, so it is that now it is the impure water, it is having some impurities or some dirt particles are there. So what you can do is that which are not soluble. Okay, so you can use this filtration method, and this is the filtration method. In this filtration method students, what we use this funnel kind of structure, and in this funnel we put some filter paper, so that what happens student, that the filter paper which we are using, they are having some pores, and from that pores only water can pass out. The other impurities will not allow to pass out through that pores. So what will happen student, when you start pouring water over that filter paper, so the water will get flow down here, as you can see, and the impurities will left behind over the filter paper. So that's how student filtration process has been done. For example, if you take the example of ROs which we use in our houses, so in that case also student, we use some different type of filter papers. It's not like that filter papers all are similar. We use some different type of filter paper. So what will happen, whether any microorganism or any bacteria that is present in the water, or any other thing which is present, so what will happen, that those filter paper will allow the water, that the pure water to come, we can say to pass through it, or some important minerals which is good for our body, so that it could pass through it, and the other impurities will left behind. So that's the filtration process. So do you notice what is sedimentation, decantation and filtration? So the sedimentation is just that settling of the sediment, that's the sediments means the solid part at the bottom of the beaker, so we call it as the sedimentation, and in the upper layer there is the clean liquid, and that is called as the decanted. We just transfer that into the other beaker, so we call it as the decantation process. And then when we have to remove the impurities and that are the insoluble impurities, so we use the filtration process. In that we require one funnel, filter paper, so that we can put that filter paper into the funnel, and the water will get passed through it, and the impurities will left behind. So this is sedimentation, decantation and filtration. Fine. Okay, so now we are discussing about the evaporation. See student, evaporation we have discussed so many times. Exactly. For example, salt solution is there, or sugar solution is there, and we have to separate out the sugar and water from it. Physically we can't do it. Exactly, that when we are having salt mixed with the water, so we are not able to pick out the salt from the water, so we can't use any hand picking method or winnowing method or threshing method at this point. So what we have to use is we have to use the evaporation method. So in evaporation method students, what happened exactly is that there is the formation of vapors. Okay, what happened, that there is the formation of vapors. How? As we know this thing student, that you can see that in this we have taken the salt solution, and you just start heating it. So when you start heating it, so what will happen, that in this what is present, it is containing salt plus water. So when as we know this thing, that the water is having the boiling point. Boiling point of water is 100 degrees Celsius. So what will happen student, when you are heating it and the temperature is increasing, so the water is also converting into the vapors. So when the water is getting into the vapors, so the salt will left behind, and that's how student, the water and salt can be separated out. Fine. And students, like if you have to see this evaporation with different point of view, how? And this method is generally used to separate out the volatile substance from the non-volatile substance. See here, volatile and plus non-volatile. What happens, students, that the volatiles are those type of the substances which convert into the vapors easily, but the non-volatiles are those substances which are not converting into the vapors easily, not formation of the vapors. So if you see the salt solution, so in the salt solution, student, water is volatile, but the salt is not volatile. So what will happen, student, when you start heating it, so the salt is non-volatile, the vapors of the salt is not going to be formed. So definitely whose vapor is going to be formed? Water. So that's how when you start heating, water converts into the vapors and the salt will left behind. So that is the evaporation, students. If you imagine that both of the things are non-volatile in nature, that nothing is going to be formed vapor, so how will you be able to separate them out by using this method? Exactly, because nothing is going to be formed into the vapor, so how you can separate them out? So for evaporation is generally used up for the such type of mixture to which are having one volatile substance and one non-volatile substance, so that when you start heating it, so one of the volatile substance is going to be converted into the vapors and the another non-volatile substance is remaining there. So that's how you can separate them out. Fine? Good. Now if we talk about the sublimation, so sublimation, student, it is also a process in which what will happen, that the solid substances, that whether we are having any solid substances, so those solid substances on heating we can say they directly convert into the vapor. And the same thing is that also, that if you cool those vapors, cooling is done, so they convert into the solid. So that is called as the sublimation process, student. Okay. So yes, what we are discussing about the sublimation. So sublimation is a process in which the solid substance directly convert into the vapors on heating and the vapor convert into the solids on cooling. So that is called as the sublimation. So students, sublimation process we generally use in such condition when we are having the mixture of substances in which one of them having the property of sublimation. Like in this picture you can see, student, that it is the mixture of iodine and sand. Now we know this thing that sand is not going to be evaporate, that means vapors. Will you be able to form the vapors of sand? Exactly, no. But what happens, student, that the iodine is having the property that it undergoes the sublimation property and it form the vapors directly. So yes, it is possible. So that's a, student, when you're having the mixture of such type of substances, that in those mixture we can see that one of the substance is having the property of the sublimation, that it can undergo the sublimation and it can directly convert into the vapors. So what will happen, you will be able to separate them out. So when you're having the mixture of iodine and sand and you want to separate them out, so what will happen, you are having iodine and sand here and you start heating it, and we know this thing that the iodine is directly converting into the vapors. So you can see here that these are the vapors of the iodine, and that's how, student, you can see that the sand is going to be like sand will present here. So that's how, student, sublimation process is used up at that point when we know this thing that okay, among the mixture, like the mixture we are having, so in that the one of the substance is having the property of the sublimation. If the substance is there, for example, if I take the example of salt and sugar, and we have to separate them out, so we know this thing that salt and sugar cannot be separated out with the sublimation process, because no one is going to be converted into the vapors. Exactly. So that's how, student, the sublimation process is used for that, we can say, for that type of mixture in which one of the substance is having the property to undergo the sublimation. Fine. Okay, I hope you got this point, that what's the sublimation. So if I ask you that what could be the other examples of the sublimation, so we can say, student, that the other examples of the sublimation is camphor is one of them, and naphthalene balls. So these are the examples of the like the substances which undergoes the sublimation. Fine. So now student, you can see that how easily we have covered up all of the techniques. Like we have covered up all of the techniques, no technique has been left now. So they all are very easy. You don't have to be worried about that, ma'am, so many techniques. But what you have to learn is you have to think that okay, what particular technique requires. For example, evaporation requires that it should having a mixture of one volatile and one non-volatile, and sublimation requires that one substance should be having the property of sublimation. Exactly. So that's how student we just have to think the property of the technique, that what type of mixture they require, so that we can separate them out. Fine. Okay. Now it's another topic, that is the solution. It is having the So it is the solution which is having the solute and solvent. Okay, so we have to see that now what is the solute and what is the solvent. Now student, yes, we know this thing that the solution we form, that we generally talk about this thing that okay, salt solution, or we can say sugar solution. And what else is student, that we know this thing that lemon juice we prepare. Exactly, lemon juice we prepare. Scent water is there. And what else, like chalk solution we have talked about. So we have talked about the solution so much, but we don't know what's the exactly the solution is. So students, solution is made up of two things, solute and the solvent. Now what's the solute is? As you can see that in this picture, that salt is that we are, it is indicating that the solute is salt. That means student, that the substance which you are adding, the substance which is added up into other substance, we call it as the solute. Okay. And what's the water is? Water we are calling it as solvent. So we can see here student that what is the exactly the solvent is. So the solvent is something in which solute is added. Solute is added. So we called it as the solvent. So solution is made up of two things, that one is the solute and one is the solvent. And what is that? The solute is something which is going to be add up. Like for example, if we talk about salt, so we add salt into the water. So salt is what? It is the solute. If we talk about sugar solution, so in water what we add? We add sugar. So that means sugar is what? Sugar is solute. And what are the solvents, student? Solvent is something in which you are adding the solute. Fine. So that is called as the solute and solvent. And when solute and solvent combine together or mix together, then there is the formation of the solution. As we can see here that the salt and water, so it is forming the solution. Fine students. So what's the solute? What's the solvent? Generally students, what happened that people differentiate solute and solvent on the basis of their amount. So what people say that the solute is something which is present in the less amount, and they talk about the solvent, that solvent is something which is present in more amount. Okay, so people differentiate over this thing, but according to me, exactly student, what the thing is that whether the less amount or whether the more amount, it's not the thing. But when we are adding something into any other thing, so we call it as the solute, and the solvent is something in which solute is going to be added, and after that we get the solution. Okay. For example, student, lemon juice. If we talk about lemon juice, see, now we know this thing that the salt and the sugar is solid form. That means solid we are adding into the water, that the solid into the liquid. But always it's not like that, student, that the solution is only about solid and liquid. It could be any other thing also. For example, lemon juice. So in lemon juice, student, what happened that we are having water in glass, and in that water we add the lemon drops. Exactly, we add the lemon drops. So what's the lemon drop is? That we are adding it into the solvent, that is in the water. So it will be a solute here, and the water is what? Water will be the solvent. And when we mix them together, so what we are getting from here? We are getting the solution. So that's how student, solute, solvent. The solute is something which you are going to add up in the other substance, so we call it as the solute. And the solvent is something in which you are adding the solute, we call it as the solvent. Fine student, now you got the point about the solution? Good. Now I'm having one question here, that what is universal solvent? Do you know this thing? What is the universal solvent? So the answer of this question is that water is considered as a universal solvent. Why? Because if anything is not dissolving in any other solvent, water is used up generally to make the solution. Whether we are preparing salt solution, whether we are preparing sugar solution, whether we are making vegetables, whether we are making the dough for the chapatis, so everywhere water is used. Exactly. So that's how student universal solvent we consider the water. That water is the universal solvent, that it is used in many ways, or you can say at many places. So for the formation of the solution. Okay. Now what the thing is, student, that as I told you that okay, solution is something which is going to be formed with the help of the solvent plus solute. Okay, so now if I ask you one question here, that okay, that what could be, what is the mass, or we can say that okay, we talking about that thing, so we can see here that what is the volume of what is the volume of sugar solution. So now if we see that they have given you that okay, sugar is added up, that you can see here that if they are taking in the volume, they are asking that what is the volume of the sugar solution, and they are saying this thing that okay, sugar solution we are taking it as the 20 ml, and the water we are taking up here, it is the 100 ml. Okay, and now they are asking you that what is the volume of the sugar solution. So what we know this thing, student, that the sugar is a solute. Exactly. And the water is a solvent. So, and now we know this thing that the solution is what? It is equals to the solvent plus solute. That means the volume of the solution is equals to the volume of the solute plus volume of the solvent. So that's how, student, when you add up this thing, so you will get the volume of the solution. So it would be 120 ml. Now you'll say, ma'am, why you are telling this question to us? Because student, when you are going to a higher classes, so definitely student, at that point you are going to find out something different about the solution, that different type of solutions are there. In that, what is the requirement is that you should know that how the solution is prepared. So how the solution is prepared? When you add solute into the solvent, so we get the solution. That means the amount of the solute and the amount of the solvent you are adding up, and in that you are getting the total amount of the solution from that. So that's a, student, you can use this method at that point, and that is why we have discussed this thing here. Okay. And it's an important question that if someone asks you what is the universal solvent, so the water is the universal solvent. Okay. Oh, that means we have completed the chapter, students. That we have discussed all of the techniques. We have discussed about the solution, solute, and solvent, and we have discussed about the properties of the compounds as well. So with that, student, we have completed this chapter. Now what the thing is, you have to rewatch this session very carefully, because it is a very important session because it is having solution and some different techniques like sublimation, evaporation. I can say hand picking, we knowing these all are very simple, but if we talk about evaporation, sedimentation, filtration, or like sublimation, so these are very important. So just watch this session very carefully and just try to remember all of these things, because you are going to use them in your future classes. So that's all. And if you have any doubt or any question after watching this video, so what you can do is you can post your question over the public or the private forum of Ask IITians, and you will get your answer from the expert side. And with that, student, we have completed this session. This session as well as this chapter also. So thank you very much, student, for attending this session.